Assalamu alaikum. Today we are going to discuss about forces and motion, and specifically the topics speed, velocity and acceleration, then motion graphs, and finally we will end with some common types of force. So let's say that we are going to start with talking about speed, velocity and acceleration. So first, to know about speed, we have to know the differences between distance and displacement. Even though we sometimes ignore the differences between them, it is crucial to know them. So let's say that I am starting at point A, moving forward 5 meters and then coming backward through A and towards until B. I am ending my journey here, and the distance between A and B is 2 meters. So here my distance traveled would be 5 meters back and 2 meters. So the total distance traveled would be 5 plus 5 plus 2, and that makes 12 meters. But the displacement would be negative 2 meters. Considering that I am taking the starting position as A and taking the forward direction as positive. Since I am taking the forward direction as positive, the backward direction would be negative, and that makes our displacement from A to B. Even though I have moved forward from A to some point called let's say C and then back towards B, even then we have the displacement of negative 2 meters. So when we measure speed, we consider distance, and when we measure this velocity, we take into account displacement. So the formula for calculating speed is total distance traveled by total time taken. So I was saying that speed equals to distance divided by time. When we calculate speed, we take into account distance. That means the number of meters I have traveled in my whole journey. But when measuring velocity, we take into account displacement and not distance. So here we can already sense that distance, during measuring distance, we only take into account the size, that means the magnitude, and not the direction. But while measuring displacement, we are taking the direction into account also. So we can say that distance is a scalar quantity and the displacement is a vector quantity. Similar to that, speed is a scalar quantity and velocity is a vector quantity. Velocity has direction. When we suppose that considering this distance positive, considering this direction as positive, when velocity occurs in this direction, velocity would be positive. When a car moves in the opposite direction, velocity would be negative. So that's about speed and velocity. Next we move on to acceleration, which is related to velocity as a vector quantity, and acceleration is a measurement of change in velocity. So when the formula for measuring acceleration is A equals to V minus U by T, where V is the final velocity, U is the initial velocity, and T is time. So while measuring acceleration, we are calculating the change in speed, but while measuring speed and velocity, we are calculating the change in distance traveled every second. So that's about speed, velocity, and acceleration. Next we will move on to motion graphs. Okay, so we were talking about motion graphs now. So there are two types of motion graphs: distance time and speed time graphs. So in distance time graphs, we put distance on the y-axis and time on the x-axis. So here we can see that the distance is being constant even though time is increasing. So that means the car is not moving at all. If this is a distance time graph for a car, the car is 5 meters from a point and it's staying at that point, it's not moving. And if we look at this graph, we can see that the distance is increasing at a constant rate as time is increasing. So the black one, we can say that the speed is low for this one. From distance time graphs, we get speed from the gradient, from the slope. When the slope is higher, the speed is also higher, and the slope is down, and not down, I meant the not as steep as the blue one. The black slope is not as steep as the blue one, so the speed is less for the black one. And here we can see that it's moving upwards and also at some kind of rate. We can say that here the car is accelerating because the gradient is gradually increasing. That means the speed is increasing, and in acceleration, speed increases at a constant rate. And here we can see that the gradient is decreasing, it's decreasing, the slope is becoming less steep. So here deceleration is occurring. Now let's move on to speed time graphs. Here we plot speed on the y-axis and time on the x-axis. When the line is like that, when there is a line like this, it means the car is moving and it's moving at a constant speed. Here I have indicated 2 meters per second. So the car is moving and is moving at a constant speed, and constant speed means no acceleration. Here in this distance time speed time graphs, acceleration is occurring. The gradient of speed time graphs gives us idea about acceleration. In the black line indicates a low acceleration, and the green line here indicates a much higher acceleration as this slope is much steeper, and gradients of speed time graphs indicate acceleration. Here speed is increasing and also acceleration is occurring, but the acceleration was not uniform. It's not occurring at a constant rate. The acceleration is constantly increasing. We can understand this from the gradient. The gradient is constantly increasing. Here the acceleration was constant. When there is a speed time graphs and the line is downward, we can say that the object was decelerating. When acceleration, the gradient of this line is negative, and negative acceleration means deceleration. That means the speed was decreasing at a constant rate. Now we will look at another graph. Let's say a car was accelerating at first when the driver presses the accelerator, and it accelerated to 3 meters per second. Then it moves at a constant speed. Then it decelerates when the driver hits the brake, and at the time 20 second, it comes, the speed becomes 0 and it comes to a stop. So from the speed time graphs, we can find the distance traveled. How can we find this? We can find by finding the area under the curve. So if we calculate from here the distance traveled for the car, we have to find the area of this triangle, and then the area of this rectangle, and then the area of this triangle. That's how we can find the distance traveled for this car moving. Okay, so now we will look into some common forces that we experience every day, but we don't really know. So one of the most common force that we all experience is the weight force. So what is the weight force? It is weight force is there due to gravitational pull of the earth. When an object is on the ground, when an object is on the ground, there is a weight force acting down from the object. Even when it's in the air, let's say the object is in the air, even then the weight force would act. It's because due to forces between two particles or two objects with masses. So as weight force acts down on an object, it might seem that the object should go into the ground, but it's not really going into the ground. And why is that? It's because of the normal reaction force. There is an upward force acting on the object from the ground, and it's called the normal reaction force, also sometimes known as contact force. It's stopping the object from sinking into the ground. So that's about weight and normal reaction force. Next, what's thrust? Thrust is the force of the engine that occurs when, let's say a car is starting to move. When it starts the engine, thrust force acts forward to move the car forward. Let's then move on to upthrust force. Upthrust force is a force that acts on objects moving through fluids. The fluid is stopping the object from sinking. Let's say there is a box on the surface of water. The box floats on water. It's because the weight force of the box is balanced by the upthrust force. So where is that upthrust force coming from? The upthrust force here in this situation depends on the amount of fluid displaced by the box. So when the upthrust force equals the weight of the box will float. But when the weight is more than the upthrust force, the box will sink into the water. As the box, let's say the box is empty, so that means it will have a low density and it will not take up, it will not have much weight, and it will displace some fluid. So we can say that the box will float due to this. But if there is some rock inside the box making the box heavier, that means the weight will be increased. That will cause the box to sink because the weight force would be now much more than the upthrust force. So that's about upthrust, and now let's move on to one of the most frequently experienced force called friction. Friction is a force that occurs, that opposes the motion of moving objects. It occurs when an object is moving through air. The air resistance is opposing the motion of the object downward. Also, when a car moves, the car does not accelerate as much as it should be due to friction, because the friction acts backward, but the thrust force acts forward. So friction is opposing the motion, and it might seem that friction is actually not is not benefiting us, but no, friction can have desirable effects too. For example, due to friction, we can move on surfaces, we can walk, because we can grip the floor with our foot and move forward. Without friction, we wouldn't have been able to grip the floor. So that's why we need friction. Also, we would miss the advantage of friction when we move on snow, or we have or when our soles of the shoes wear out. When we move on ice, there is not much friction acting, and it's much difficult to walk on ice. Also, and another example I was giving about soles of the shoes wearing out. That means the shoes, underside of the shoes become flat. That means the shoes cannot grip the surface strongly, and a lack of friction. That means we will slip, we will be slipped when walking. So that's all for today about forces and motion. Thank you.